Hi students, we are getting into a new chapter, chapter 6, and in this chapter we're going to be looking at a lot of inequalities, working with greater than, less than, greater than or equal to, and less than or equal to. So this first section is solving one-step linear inequalities. So I have this chart right here. I do want you writing this chart down. The verbal phrase, the inequality, so the inequality that matches the verbal phrase, and then writing down the graph, because these are examples of what you're going to be working with in this first section. So as I mentioned, you're working with the less than sign. We always think of the less than sign as like the tip of the sign itself directs the variable or number on the left side. Greater than symbol, it always opens first, like a mouth. Less than or equal to, notice it has the line underneath. Greater than or equal to has the mouth opening first with the line underneath. So looking at this first verbal phrase right here, it says all real numbers that are less than 2. So how would we write that as an inequality? It would be x is less than 2. And then we have to graph this. And so what we do here, if x is any number less than 2, we're going to start with an open circle at the number 2 on a number line. The open circle, the open dot, is used for the less than or greater than symbols. So we have an open circle shading to the left. When it's less than, you shade to the left. When it's greater than, you shade to the right. So x can be any value less than 2. So x, it could be -3, -2, -1. So this first graph here represents x is less than 2. The next one, all real numbers greater than -2. So here we're going to set up the inequality based on this verbal phrase. So x, this is the greater than sign, x is greater than -2. Notice it's just the greater than symbol, so we have an open circle at the value -2, and x is any number greater than -2. So that's where we shade to the right on the number line right there. Now working with less than or equal to, greater than or equal to, notice the note down here. When you're working with less than or greater than or equal to, it's going to be a closed in dot. So here we have all real numbers that are less than or equal to 1. So the way we write that is x is less than or equal to, notice the symbol, 1. So here we have a closed dot at the value 1, and x is any number that is less than or equal to that, which means x can be any number, or it could be 1. It could be equal to 1 as well. The last situation in this graph here, it says all real numbers greater than or equal to 0. So the way we'd write that is x is greater than or equal to 0. We have a closed dot at the value 0, and x would include 0 or any number greater than that. So that is the graph that represents that verbal phrase and the inequality we wrote there. Let's try an example ourselves here. It says John was sure that he didn't score less than 73 on his algebra test. So he was sure that he didn't score less than 73. So what that means is he thinks he got a 73 or more on his test. So what we need to do here is we need to write an inequality based on that, and then we're going to graph the inequality that we write down. So John was sure he didn't score less than 73, so we'll have x be the number, any real number. So x is going to be greater than or equal to 73. Why is x greater than or equal to 73? Well, the situation is saying John was sure he didn't score less than a 73. So that means John scored a 73 or more on his algebra test. So the way we'd say this is x can be any number greater than or equal to 73. So the way I would graph this is I write my number line, 73 is a pretty big number, so we don't need to start on the number line right at 0. So I can just put 73 here in the center. I'll write a few numbers above 73 and a few numbers below 73. Okay, so x is any number greater than or equal to 73, so I'm going to have a closed-in circle here. And x is any number that is 73 or greater than that. So I'm going to shade then to the right. Remember, greater than you shade to the right, less than you shade to the left. And this graph right here represents the situation, and here is my written inequality based on the sentence above. Here's some more examples here where we're working with solving linear inequalities. So solving linear inequalities is much like solving linear equations. To solve inequalities, you need to isolate the variable on one side. So I do want you writing this down because that's important. Solving inequalities is just like solving equations. So what we're going to do is we're going to solve the following situations and then graph it with an inequality. So for A here, we have x minus 3 is less than, this is the less than symbol, 5. So we want to isolate x, which means get x all by itself on the left side here. So what I'm going to do is add 3 to the left side to cancel out the 3's, but I have to, whatever I do to one side, I have to do the same to the other, so I'm going to add 3 to the right side. So 5 plus 3 gives me 8. So I have here x is less than 8. So now that I have solved my inequality, I'm going to graph this. So I would start at the number 8. We actually are off that here on this number line given in the example, so I'll just add in the 8. X is less than 8. So what I'm going to have is an open dot at the value 8. X is less than, so I'm shading to the left. So x is any number less than 8. It does not include 8, but any number less than 8. And that is my graph that represents that situation. The next one here, we have x plus 6 is greater than or equal to 10. So again, we want to isolate x, meaning getting it by itself. So I'm going to take the opposite of adding 6. I'm going to subtract 6 to both sides. On the left side, the 6 cancels out. So I'm left with x is greater than or equal to 10 minus 6 gives me 4. So that is my written inequality, but now I need to graph it. So don't forget there's two parts to this, solving it and then graphing it. Here we have the symbol of greater than or equal to. So since we have that line underneath the equal to sign, that is going to be a shaded in circle starting at the number 4. X is greater than or equal to 4, so when it's greater than, we shade to the right. So I'm going to shade everything here to the right on the number line. So what this means is x is going to be 4 or any number greater than 4. Which makes sense because if I were to plug in 4 in for x, we need to make this inequality true. So if I did here 4 plus 6, is that greater than or equal to 10? Well, it's equal to 10, so that would count. Or I could do 5 plus 6. That is greater than or equal to 10. That's 11. So both of these situations are true. Whereas if I had 3 plus 6, that is 9. That is not greater than or equal to 10. So that would not be a true situation. Same goes for A here. If I were to plug in 8 for x, (8 minus 3) less than 5. 8, 7, 6, 5. Well, that's equal to. So x has to be any number less than 8. So if I put in here 7, 7 minus 3 gives me 4, and is 4 less than 5? It's true, so that situation works. Whereas if I just put in 8, that would make it 5, which is equal to, so that would not work. So when you're solving with these inequalities, you're finding a number that makes this situation true right here. All right, so here's this definition. I want you to write this down because this is very important. It's going to help you through this chapter and here on out working with inequalities. When you're working with linear inequalities, like we said, they're very similar to solving equations. But when it comes to multiplying and dividing linear inequalities, there are some differences. When you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol to make the statement true. This should say make. I'm sorry about that type error. To make the statement true. So in the previous example, how I was showing you the numbers we solved for made it true. When we're multiplying and dividing and working with the negatives, we have to reverse the symbol to make the statement true. So write this down, please. And then on the next slide, we're going to get into some examples and I'll show you how this works. Okay, so here we go. We're going to solve and graph the following inequalities. So here for A, we have 1/2 x is greater than 3. So I'm just going to write it like this because you'll see how it makes it a little bit easier to work with this fraction right here. So 1/2 x, we need to isolate the variable, meaning getting x all by itself here on the left side. So I want to get rid of this 1/2. Well, what's the opposite of getting rid of a fraction? Is multiplying it by the reciprocal. So if I multiply by 2/1 on the left side, I need to multiply by 2/1 on the right side. On the left side, half now cancels out. So I'm left with x is greater than, now we multiply here. 3 times 2 gives me 6/1, which just simplifies to 6. So this is my inequality right here. Notice we weren't working with any negative numbers, so we didn't have to switch the inequality here. So we're just going to graph this. So x, to make this inequality true, x has to be any number greater than 6. So we could have, let's say, x equals 8. Half of 8 is 4. 4 is greater than 3. So that's a true situation. So x is greater than 6. Here I'll have an open circle at 6. X is greater than, so we're going to shade to the right. Does not include 6, but can be any number greater than 6. And this graph represents the situation. Let's look at B here. We have 3 times x is less than or equal to 9. Again, we're going to isolate x. We're going to get x all by itself on the left side. So we're going to divide. Opposite of multiplication is division. Inverse operations, we call that. 9 divided by 3 gives me 3. So what I have here now is x is less than or equal to 3. Which makes sense because 3 times 3 is 9, which is equal to 9. If I did 3 times 4, that's, x has to be less than 3. So if I did 3 times 2, if I had x equals 2, that would be 6. 6 is less than 9. So this is true situation based on the question they're asking. I'm going to have a shaded in circle at 3. X is less than or equal to 3. The reason it's closed in is because I have the equal to sign. X is less than, so I'm going to shade everything to the left. So x can equal 3 or anything less than 3. And that is my answer for B.